In the question, it is given that x is a random sample from an exponential distribution with mean 1 by lambda. So we can write f of x given lambda is equal to lambda e raised to minus lambda x. And the prior distribution of lambda is given as g of lambda is equal to lambda e raised to minus lambda for lambda greater than 0. We have to find the base estimator of 1 by lambda with respect to the squared error loss function. So first of all, we have to find out f of lambda given x. The conditional distribution of lambda given x. We know that it is proportional to f of x given lambda into f of lambda or g of lambda, which is again proportional to lambda square e raised to minus lambda into x plus 1. This is somewhat similar to a gamma distribution, but the constant term is missing here. So to make this a probability density function, we have to multiply the function with x plus 1 that whole cube divided by gamma 3 into lambda square e power minus lambda into x plus 1. So the conditional distribution of lambda is now a gamma distribution. Now we have to evaluate the base estimator of 1 by lambda with respect to the squared error loss function. So expectation of 1 by lambda is equal to integral range over lambda 1 by lambda into f of lambda by x or lambda given x d lambda, which is equal to integral range over lambda is 0 to infinity 1 by lambda into x plus 1 that whole cube by gamma 3 lambda square e power minus lambda into x plus 1 d lambda. The integration is with respect to lambda, so we can take x plus 1 that whole cube by gamma 3 outside. Integral 0 to infinity lambda power 2 minus 1 e power minus lambda into x plus 1 d lambda, which is equal to x plus 1 that whole cube by gamma 3. This is again a gamma integral. The result of the integral is gamma 2 by x plus 1 that whole square, which is equal to x plus 1 by 2. So the answer is the base estimator of 1 by lambda is x plus 1 by 2. So the fourth option is